To find out if a number is prime or not, you just need to divide by all the prime numbers that go up to the number's square root. So 71, for example, 8 squared is 64, 9 squared is 81, which means the square root of 71 is going to be less than 9. So I just need to check the prime numbers 2, 3, 5, and 7. In this case, I can see it's 71 is not even. The digit sum is 8, so it's not divisible by 3. It doesn't end in a 0 or a 5, so it's not divisible by 5. And 7 goes into 70. There's a remainder of 1 if we divide 71 by 7. So this one is prime. Now, why do we do that? Because why do we need to not go beyond the square root? Because if the no number below the square root goes into it, then there's not going to be a number above the square root because factors always come in pairs. And so if 2 did go into it, then there would be, like for example, 70, then you would get 35 at the other side. So you can't have a number the other side of the square root that's bigger than the square root, but then not a number below the square root. So we just go below. And we don't need to try out things like 4 or 6 because 2 goes into 6 and 2 goes into 4. So 2 doesn't go into 71. There's no way that 4 would or 6 would, for example. So that's a little bit of background on that. We just now need to apply this idea to 457. So 20 squared is 400. That's kind of a good starting point. 21 squared is going to be 441. I mean, you can do a column multiplication, or you might just know it, or you could do 20 plus 1 times 20 plus 1, expand these double brackets. You're going to get a 40 from here and another 1. That's where that comes from. Okay, and then I think 22 squared is definitely going to be bigger because you can see that going up. Actually, we just need to now add on 43. That's how you could do it quickly. So you get 484 because you add on an extra odd number every time. Or we could do it by hand. But anyway, what we see is that the square root of 457 is going to be less than 22. In the same way as 71, I just now need to write down the prime numbers that go up to that. 2, 3, 5, 7, and then 11, not 9. So now it's just odd numbers. 13, not 15, 17, 19, and 21 is 3 times 7. So that's it. These are all the prime numbers we'd have to check, which means there's 8 prime divisors we need to check to see if 457 was prime or not. And you could apply this in any scenario. They can see as numbers get bigger, you're going to have to think of a lot of prime numbers to divide by, and you're going to have a list of all these prime numbers. So if you start looking at numbers that are like, have 100 digits or something, this method is going to fall apart, and there are other ways to investigate if numbers are prime. But for a first kind of go at it, this is a really good method. We don't have to divide that by that many things to see if 457 is prime.